Hey, what's going on, everybody? Welcome to this edition of the Improving National Lunch and Learns. My name is John Ruzick, and today we're going to be talking about a pretty cool topic called Microsoft Project Tye and how you can simplify microservice development using this, to be clear, experimental tool from Microsoft that's been released recently. So very quickly, just about me, senior consultant here at Improving, been here 5.5 years, going on 6 actually this summer. Some past projects that I've worked on is some desktop application development, integration with SSIS, BizTalk, some front-end Angular, JavaScript, and then most recently doing a full-on microservice architecture design and implementation at a client. So that's where that leads us into this. A couple passion projects of mine. Kegbot is a kegerator monitoring application, open source thing that I participate in. Product called Octavox I've created, which allows Alexa to talk to 3D printers. And then just a real simple golf tips app that you can use on your Apple Watch or on your mobile device. So a couple of things and some background about me. So what is a microservices architecture? So it's pretty simple and at a high level. It's just an architecture that separates the application into discrete services, each serving a specific business function. And those services then are loosely coupled and communicate either via APIs or asynchronous messaging patterns. So a lot of times you compare a microservices architecture to a monolithic application where all of your code, everything is one huge application, everything's built in, whereas microservices, each function within that application is really designed to be its own app. And some of the big players that have been in the news with this microservices as this buzzword is kind of taken over. Netflix is probably the first one that jumps to mind. They use that microservice architecture for nearly all aspects of their applications. So video transcoding, content delivery, user account management, the recommendation engines that pop up and show you, hey, if you like this, you may like these other things. So all the intelligence and all of the features and functionalities that Netflix has are built upon a microservice architecture. Walmart is one that you might not think of as being particularly innovative in the technology space, but they've pretty much completely transitioned to microservices to accelerate their development and deployment for everything from their mobile app to some IoT implementation things that they're working on. And then Uber, this is actually, if we share out this presentation later with these links, it's actually an interesting article, how they re-architected their environment that had really 2 monolithic apps into an environment today that leverages over 2,200 microservices. And it's pretty interesting reading that article, just thinking about how Uber started, right? It was originally just the black cars that could pick you up, and now it's anyone can be a driver, now to things like Uber Air with helicopters in New York City. Uber Freight now is a new service where you can use Uber to send large packages or freight across the country. And with that microservice architecture, they've been able to easily spin up and add on features and functionality into their existing apps, where trying to do that in a monolithic infrastructure or monolithic architecture could be a lot more challenging. So what does a microservice architecture look like? So at a kind of ultimate pie in the sky textbook example, the big idea is you separate the services and the entities that they control into their own unit. So you can see here on this diagram, each service also is coupled with its own database. So this service manages its own entities. And this gives you a lot of flexibility. If you notice on this diagram, the services here don't have to be written in the same language. So if you've got your authentication service, your identity service, maybe that's a .NET Core, or you're plugging into a third-party cloud-hosted service, right? Your ordering service may, for one reason or another, the team is most familiar with Node, so you can write that service in Node, or some other service, maybe it's doing machine learning, one of the things that Python is really good at. As well as on the database side, if some of these items need a relational data store, like a SQL Server, that service can use SQL. But in some other cases, if it needs a NoSQL implementation, you can plug into a Mongo. So you aren't tied to a single database technology or a single programming language per service or for your entire application. The other pieces of this is typically an API gateway that will control access to these services and allow either a web user through a web application or a mobile user on a mobile app to all consume these services without building a specialized mobile service or a specialized web application service, or even if you've got a desktop app, a specialized service for that desktop app. So these services, by breaking them up and splitting them out, you've got flexibility in your languages, in your backend data stores, and then you can expose them to pretty much any front-end environment that you want. And then if you do need to communicate between services, you can always make an API call or a gRPC call or one of those other communication technologies from one service to the other. But a lot of times what we'll leverage is some type of message broker or a message bus. And this allows for asynchronous communication between services. And what this gives you, and we'll talk about some of the benefits later, is it does give you the opportunity that if one of these services needs to kick off a message, and maybe it doesn't require a response from another one, but it needs to notify it of something. If that other service is down, your message broker can handle that and everything will run just fine. And then when that service comes back up, the message broker can handle delivery of that message to that service once it comes back online. So what does a typical microservice stack look like? And this is where, and we'll talk about this in a few slides, it can get really complex. So down here in the bottom right-hand corner, you see your application code. So I mentioned before, it's kind of language agnostic. You can have Python, .NET Core, Node, Angular. And then what you usually do is you'll package that code into a container. So a Docker container, right? So you'll package that up and then deploy that container to a container registry. And then there's Helm charts that describe how those things get deployed. And you'll have a chart museum that stores those Helm artifacts. And then you ultimately get to something like a Kubernetes cluster or an app service fabric, something of that nature. But Kubernetes, I think, is kind of leading the way across the cloud landscape. And then you'll get those containers deployed onto your cluster or into your container orchestrator environment. And then that's actually how they're hosted and deployed. And then along with that, so you've got your .NET Core application, for example, those need to talk to a database. So you've got all these shared dependencies out there. So either SQL Server or a Mongo or a Postgres. And then your message brokers, Kafka, Azure Event Hubs, RabbitMQ. And then your typical things for an in-memory cache like a Redis or a Memcached. Right, so you've got all of these different pieces that play together in this microservice stack. How do you develop these? How do you start up even trying to create this and debug this and get things going? So I touched upon this a little bit ago, but what are some of the benefits? So these services can be independently built and tested. So if I need to only make changes to my identity service, because it's not sitting in a monolith that's on its own island, I can, in most cases, just make changes to that application, push it through a QA path, and then deploy that application without touching any of the other services. I mentioned this before, they can be written in different languages. They can be independently deployed and scaled. In the case of Kubernetes, a container orchestration environment, you absolutely could take a monolith, containerize it, and throw it out onto Kubernetes. But in order to get more replicas of that or scale it out, you're now scaling your entire monolithic application. Whereas if you've broken it down into these microservices, let's say a customer update service might not get hit all that often, but Black Friday comes along and your ordering service is getting hammered. You can independently scale that ordering service out while keeping your other services at a more nominal scaling or just replicas for high availability if they're able to just handle that load, as opposed to trying to scale the entire application. The database platforms can be selected based on individual service performance and functionality requirements. You aren't tied to one across your application stack. And in many cases, containerized applications are OS and platform agnostic. So if you can build these services and get them into containers, you can run it on Linux machines. You run it on Windows machines if they're running the container engine. Run it on an Azure platform, AWS, Google Cloud, you name it. If you've got it in a container, you can largely lift and shift across any type of OS technologies or cloud platforms for that matter. So what are some of the challenges? So one of the biggest problems with microservices is it is always more complex. It sounds great that, oh, if I've got these small little applications, I can just make changes to them, and that's certainly a benefit. But how do you get this application to talk to some of the other ones, or this service to communicate with other services? So it is always complex, and designing the application in such a way to kind of limit cross-service dependencies as much as possible is a big challenge as you're trying to develop one of these. So for example, if you're doing something like an accounting system, right? How do you handle distributed transactions across multiple services? Or do you even try to do that? Do you try to combine those all into one service so that you can have atomic transactions? Testing the entire system, as opposed to a single service. Yeah, I can easily test my single service if I'm doing development on it. But how do I test that within the context of all of these other services that are out there and may already be deployed? Troubleshooting service faults and application failures. These requests could go across services. So how do you trace that down? How do you track that down and find out where the root cause of the problem is and follow that flow through the message bus through to different services? And then kind of keying off of that, the inter-service communication reliability and performance. If I needed to call a function inside my monolith, it's right there in the application code, right? Now if I need to call something in another microservice, I'm now relying on network communications, message brokers, things like that. So that reliability and performance is something to consider as you're building these microservice applications. So specific to myself and probably many of you joining, the .NET developers, what are some specific challenges for us? We try to build this out in a .NET world. So running multiple projects, right? If these are set up as different projects, how do you run and debug them? Now, Visual Studio has better tools now. They've come a long way to setting up the debugs of setting up multiple projects. So there's solutions there. So we've kind of got that solved. It's not super intuitive or easy, but you can solve that in Visual Studio. But service discovery. So now I've got multiple web apps that I'm trying to debug at the same time. How do I know how they communicate between each other? Port conflicts, hard-coded URLs to try to get things to run all at the same time on my machine and debug everything. And then what do I do about dependencies? If I've got Mongo, if I've got SQL, if I've got a message broker like RabbitMQ, do I need to set up a full SQL installation, a full Mongo installation, a full RabbitMQ installation on my Windows box to try to meet those dependencies and have those in so that I can debug this application. So with Docker and the Docker Compose tool, do we already have solutions for this? And in some case, yeah, containerization absolutely helps huge with this. So it solves the multiple project and the dependency problem. If I'm running an application that requires SQL, I can run SQL in a container, put it in my Docker Compose file and spin up a SQL instance. If I also need Mongo, great, spin up a Mongo container. If I need to run multiple .NET applications, put them into containers and then set up the Docker Compose to run those containers and run those multiple applications. The only issue with that is it's kind of a steepish learning curve. You got to learn Docker files, and you got to learn Docker Compose and get familiar with the networking and the concepts around that before you can really get started to build this out and develop it. So how does Project Tye help? So Project Tye has two main goals, and that's to make development easier by running many services with one command, using all of those dependencies in containers, like I mentioned, SQL, Mongo, and then provide a method for easy service discovery. And then making deployments easier by automatically containerizing your .NET applications, generating Kubernetes manifest files with minimal knowledge or configuration, and then all of your configuration can be kept in a single file. So some of the main features of Project Tye, and I'll jump in here and just say one thing. Project Tye is still very much an experimental tool, and I'll show you that right now. And so those were their goals, and they're working the way to meet all of them. But and they're getting there. I want to give everybody just a head start and show kind of what this tool can do for accelerating this. But some of the main features currently is the service discovery via configuration. It natively understands .NET project files and is able to containerize them. Provides a dashboard for metrics and logs. It runs Docker dependencies. So we talked about that before, the SQL or Mongo or anything else that runs in a Docker container. It'll run those just fine. And it will build any Docker file, not just .NET projects. If you give it a .NET project, it will do its thing kind of automatically. But if you've got a already set up Docker file, point it at that and it'll build it and run it just fine. And then it will, I don't know if this is a word, but Dockerize your application and deploy it to Azure Kubernetes service. And then it also supports hot reload. So as you're running your application with Tye, if you make changes, it will automatically reload and you'll see those changes pop in. So I'll do a very simple demo here before I get into some more advanced stuff. Does anyone have any questions or has anything come in on the chat? Yeah.
No questions yet.
Good deal. Good deal. So we'll jump in and do a very quick kind of simple demo to show you kind of how this works. So this is my demo app. Pretty simple, right? A front end and a back end. So what I'm going to do is I will jump to this guy and also bring up, let me get out of my presentation. This will make things a little bit easier. So this is a starter solution that I've got, and I'm just going to do this, Tye run, and I'll give it that watch command. So you'll see it starting up, and you'll see it started the dashboard. See it launching services. Here's all my replicas are starting up. And if I go and open up a web browser here to port localhost 8000, this is the Tye dashboard. So we have the ability to see all of the services that are currently running. You can view logs for that service. Go back, if I click on front end, you can see all of the different metrics for it and get a good idea of what's going on with your solution. And you also then get these automatically created bindings. So it automatically spun this up and hosted it here on 55558 and then 55560 for this backend. And it did that automatically. It's going to pick ports and set those up. So if I click on this front end and bring it up, you'll see this is probably look familiar to a lot of .NET developers if you're getting started with a web project. This is just the typical weather forecast. And if I click on this URL here for the backend, I'm not going to get anything because this is just a web API. But if I go to the Swagger doc, you can see we're up and running with this backend service. So with one command, I was able to bring up this microservice application with a front end and a back end, and they are communicating with each other. I will show you that. If I refresh, you'll see these these summaries pop in. If I go and look at the code here on this is the back end. I'm going to add one in, and I'll bring up this. I'll see if we can show you this here. I'll go ahead and save this. Quickly bring this up. What you'll see is file was changed, refreshing. All right, we're all good. It came up. And now if I go back to my web browser and refresh this a few times, there we go. Now we're seeing Death Valley show up in here. So front end communicating with the back end, really simple. And then with that watch support, you're able to make code changes and it'll automatically pick it up. So let's look at a couple things just in the code here. I'll jump over to the front end. One thing I do want to point out here is, and I'll promise you this is true. One thing you'll see in here is there are no Docker files. None. This is just a web API project, ASP.NET Core. No Docker files. Just by pointing Tye at these projects, it was able to build them, containerize them, and spin them up. So talked about native .NET support. This is it. With these project types, it's able to natively spin them up and containerize them without having to write Docker files or anything like that. If I look at the service discovery, we'll get into this too when we go to the more advanced demo, but we look at service discovery. Project Tye gives us this extension method. And that comes from, if you're installing Project Tye, you need this Microsoft Tye extensions configuration NuGet package. But this will get you this extension method. And you'll notice that just get service URI for backend. So this is my project name is backend. So give me the service URI for that. This will automatically, when this gets started up, grab, if I go to the dashboard, grab this URL right here. And so if I restart this and change it, which I can do right now, I'll stop it and run it again. What you'll see is we're on different ports now. But if I open this version of the front end, it still works. So that service discovery capability of Tye allows you to spin up these projects, and it will automatically figure out where all of these dependent services are being hosted, and then direct them to that when you configure it with that Git, with this extension, the Git service URI. So that's pretty cool. Just a good kind of simple demo. One of the other things that I'll just point out about this really simple demo is if I list all the files in here, I've got a solution file and then I've got my project files. I don't have any configuration files whatsoever. With just a simple project like this, if it's just .NET, I can run Tye run and it will automatically just figure things out and come up and things will work. Things get a little bit more complicated when you have multiple services and you've got different dependencies and things that you're relying on. So we'll take a look at that now. So you probably don't need to show this. So this is Tye. This is just a microservice application that I've put together that kind of demonstrates all of the things that I've talked about here before. So multiple different services, photo service, a processing service, so multiple different languages. So .NET Core for the services. We've got a SignalR service down here, MongoDB, a RabbitMQ message bus. So a lot of dependencies with Rabbit and Mongo, services in different languages, Blazor web app, front end. So a lot of different things going on here in this application. And so if we take a look and jump over to that, I'll bring it up. And so what this is doing is here, it's bringing up all of the containers and projects and things that I've defined. And if I go back to my, I'll close these. If I go back to my dashboard here, you'll see we've got a lot more services running now. So you'll see we've got RabbitMQ instance up and running. We've got Mongo instance up and running. We've got this photo processor service that's just a container because this is a Python application. And then we've got our .NET application. So you'll see the source path to the CS_proj file that hosts that application. So pretty cool. And then I can go and click on this link here, and this will launch Blazor and give me my application. I can show you here some of the data flows and how the requests flow through the system. I can go to my photo gallery, and I know on my slide it was talking about ice cream, but it's a Friday, so we're going to do some local breweries here. So if I upload that, it goes in. The photo processor is just doing some enhancements on it, and this is all via SignalR. It's processing. Once the processing is completed, send a message to SignalR that, oh, and then I reload this page and get the full screen. And just demonstrate that it does work, we'll pull this over into another window and new comment. If I write a comment here, I should see that comment show up here on the other window. So you've got SignalR running via .NET Service, messaging going on with, hey, I posted a comment, let's send a RabbitMQ message over to the notification service to actually generate that SignalR request. If I'm making a comment, that's actually going to the comment service. If I'm posting a photo, that's going to the photo service. So we've got things set up here in a microservice architecture and just running with Tye with pretty much one command. Now things get a little bit more complex though with this, and that's where this Tye.yaml file comes in. And this is the, as I mentioned before, all of your configuration in a single file. This is that single file. So Tye.yaml will define certain things like the name of the application, and then the primary or the bulk of this is going to be services. Here you can also define a container registry, and I'll show you that here here towards the end of the presentation. But these services are where you define your projects and what things you want to spin up, as well as a bunch of other configuration things that apply to Kubernetes that Project Tye allows you to debug locally. So for example, my comment service, I just give that service a name and point it at a project file. Same thing with my photo service, since that's a .NET Core application, point it to that. These things here, liveness and readiness, these are health checks that Tye is going to do to make sure that this application started successfully. So liveness is going to check to make sure that the application started. Readiness is going to check that all of the dependencies have been met. I can connect to my database. I can connect to my message broker. And then once this ready is successful, then it will actually start routing traffic to this service. So liveness, it will check to make sure it's up. If it's failing these liveness probes, it will restart it. Readiness, if it's not ready yet, it just won't route any traffic to this service until it is available and passes that ready check. My notification service, again, another CS project, but I've added things here. I want this, instead of picking a dynamic port, I always want it on 55555. So I can define that here in my Tye YAML file. This photo processor application I mentioned, that's a Python app. So I've written a Docker file that takes a Python application and containerizes it. And so I'm pointing Project Tye to that Docker file location. I'm also telling it, hey, give me 3 replicas of this that I can use. And then this Python app takes a few environment variables that define how to connect to the RabbitMQ message broker. So I'm passing those in as environment variables. Here's my front end. Again, another CS proj file with setting up, I just want this on HTTP, and then some environment variables here that allow me to define whether or not I'm deploying this to my development environment or a production environment. And then we get into what's cool about Project Tye is these dependencies. So Mongo, I didn't write Mongo. I know it's hard to believe, but I did not write Mongo. But somebody did, and it's out there, and there's a container image already available for it. So I'm just going to pull the Mongo image, and this is going to go out to Docker Hub and pull that down, and then pass in some of the environment variables that it uses to set itself up. I'm going to tell it I want it on these ports, and then I can actually give it a connection string property as well. And this is used in service discovery, and I'll show you that. I can also, if you're familiar with volume maps, map the container storage to storage on my local device so that through restarts of this Mongo database, I can actually persist data. And then finally down here, RabbitMQ. Again, didn't write RabbitMQ, but I can pull that container image directly from Docker Hub and have Tye do that, pass in the environment variables for that, and then set up bindings. In this case, I'm using the one with the management interface. So I'm defining my actual message broker port and then the management interface port to expose those. And then finally, Project Tye also supports the definition of ingress. And so ingress, if you're not familiar, is really a layer 7 load balancer that allows you to route based on different things, but primarily paths. So what I've got set up here is on port 8080, I'll have this ingress port set up. And then if I hit these URLs, it's going to route this traffic to the photo service API. If I hit /API/comments, that traffic is going to get routed to the comment service. And then this photo Tye hub is going to route and connect me to my SignalR notification service. And any other path that I hit will take me to the front end. So now that this is up and running, I can actually also do something like this with this ingress. So the service itself is running on a different port, but 8080 without any endpoint is going to route me to the front end. And then all these web requests are going to have those API paths tacked onto the URL, so it will route those appropriately. So in this more advanced scenario, I'll show you again, there's two ways to get those service discoveries that get service URI. And for this, I'm setting up my RabbitMQ instance. So I'm going to get my service URI of the type RabbitMQ. And if you remember back on my Tye YAML, I actually have multiple bindings here. So I'm going to tell it that I want this one. So I'm going to connect to the RabbitMQ broker port here. So the binding I want is RMQ. So that'll get me that service URI, and as this starts up and dynamically picks ports, this will automatically figure that out and know where this RabbitMQ service is hosted and how to connect to it. The other option down here is for Mongo. So I've defined a Mongo connection string in my Project Tye file. So here it is, MongoDB, host, and port. So I can reference this using that same extension method here, or extension NuGet package, to get that connection string from Mongo. So this will not only return just the URI that Tye generated, but it'll return a connection string that I define. And if you saw those variables in there, will be dynamically created. So this is a great way to do service discovery and really just dynamically connect to things, whereas otherwise I'd have to start up Mongo and then hard code in here where it is, and then when I went to deploy it somewhere else or move to a container, I'd have to go back in here and change this. Running with Project Tye, this line here will automatically take care of that service discovery. And going into a little bit more detail about that service discovery, if I look at the logs for this photo processor, that Python app, what you can see is this is just building that Docker file. And then this is the command that it's actually running. So Docker run, and then it's going to pass in these environment variables to that container. And what you'll see here is you'll see a ton of environment variables, and these are all generated by Project Tye. And so it uses a known pattern for generating these environment variables, but for all of those services that I've defined, you'll see it service, comment service API, the protocol is HTTP, this I guess alternate version of the environment variable HTTP, what port it's on, the host name of it, the different protocols. So here for HTTPS protocol. So all of these are environment variables that get injected by Project Tye when the containers start up. And so under the hood, all of this is doing, this get connection string, Mongo, is reading from the container environment variables at runtime to get this connection. So it's a pretty cool way to easily spin up and debug multiple services and really run an entire microservice application locally without a lot of headache of setting things up and configuring it. Project Tye abstracts that away in a pretty amazing way from what I've seen. So we go back to the presentation here. So now it's running locally. Let's talk about deployment. So Tye, I've been running the Tye run command, right? So that's going to run things locally. But Tye also has that second goal of making deployments easier. So Tye has a Tye deploy command. So what Tye deploy is going to do, one difference between that and Tye run is that it will not deploy your dependencies. So things like Mongo or RabbitMQ. The idea being, if I'm going to deploy this to an environment, I've already got a message bus out there. I've already got databases that I want to connect to. So what Tye is going to do, and I'll show you this, is prompt you to provide that information as part of the deployment so that it can then connect to it and leverage that. It's going to create my Docker containers, and it will then push them to a container registry. So you give it that container registry that I mentioned before. I was pointing it to one that I've already got out there in Azure. So it will containerize my application, push those to that container registry, and then it will run Kubernetes manifest files to deploy those pods and services to a Kubernetes cluster. And then it will also deploy and configure an ingress controller. So if I do that, I've already got a Kubernetes cluster up and running out there. I'm going to make one adjustment here so you can see this works. I'm going to change my environment here from development to prod. So we'll save that. This is shutting down the one running locally. And when this wraps up, I will show you. If you're familiar with Kubernetes, connected to a cluster that I've already got in Azure Kubernetes Service. You see, I've already got Mongo and RabbitMQ running out there. So trying to simulate kind of how it would be in the real world, I've already got some of these dependencies out there. So what I can do from this directory now is Tye deploy, and what I'm going to do is I'm going to pass it the interactive flag, so -i. And this is required because of the dependencies. It needs to know those connection strings and that information. So if I do Tye deploy -i, it's checking my Kubernetes connection, and now it's going to start with the first one in the list. It's building that Docker file, containerizing that application. It's going to push that Docker file to that container registry, and now it realizes that that application needs these dependencies. So it's going to prompt me for them. So this is for Mongo. So I need to give it, make sure I get it right, give it the connection string for my Mongo dependency. And now it also needs a RabbitMQ instance, so I need to give it that. So if you remember, I had declared not only the message broker interface, but the management interface, so the web UI. So there were two bindings for this service. It's going to prompt me for both. So the only thing I don't like, if I'll point it out here, it doesn't tell you which one it's asking for. It tells you which one it created, but it doesn't tell you which one it's asking for when you give it this. So that's just one kind of bug or thing that I'm sure they'll correct as more versions are released. Cool. So now that I've given it that, it will continue to go through. Now these other services depend on those same dependencies, but I've already given it the connection strings to those dependencies, so it will just use those that I've already given it. So it's going through building the containers. If it's, like I said, the Python app, if it's a Docker file, it'll build that Docker file. If it's a .NET app, it just can natively build it and create it and publish it. So it's writing all of this out to my container registry. Despite the red text, it is successful. And so push it all out there. And now it's deployed things to Kubernetes, and now it's also deployed that ingress controller. And what it's going to do in Kubernetes is create that ingress controller and services with a type of load balancer. So now it has given me a public IP address where I can hit my application. And so I've got a host file set up to where I can hit it via a URL, but if I go here, this is actually running in Kubernetes, deployed that same application that you've already seen, connected to Mongo. I can go to my photo gallery here. Upload pictures, get the photo processing. Once it's done doing its thing, it should pop up and show me the full screen image. I can do the same thing here if I write a comment. I get my comment there, and it shows up on the other window. So SignalR is sharing that information across browser instances, or if somebody else was logged in and I made a comment, it would show up on their screen automatically. And theoretically here, this is public. I've got things set up, but yeah, somebody can add a new photo. So somebody just added a new photo, so I can refresh this gallery and get a hilarious picture of our friend Jason Russell. And that shows up. So Tye can allow you, just with that one command and giving it a couple parameters, can actually deploy this out to a Kubernetes cluster, and it's up and running. And then once you're done with it, if you're doing development or testing, you can run Tye undeploy. And this will go out and it knows what it deployed, and then it will undeploy everything that it deployed. So if I do this, you'll see Mongo is still running, RabbitMQ is still running, but my comment service, my photo processors, my photo service here are all terminating. So Tye was able to just tear down the stuff that it created, but leave the dependencies that were out there. And in this case, I mean, maybe you aren't running Mongo in your cluster, maybe it's a Cosmos DB hosted somewhere, so it wouldn't tear it down anyways. But if it is in this case, Tye's only going to touch the things that it deployed and created. So we'll go back here and just wrap up the slides. I don't like that it always does this, but that's good. So just to talk a little bit about current limitations and issues. So this is very much an experiment. Even Microsoft will tell you it's not production ready. Now, there are some pieces of this, I'll talk about that maybe you could use in production right now, but this whole flow of everything, there's a lot of just little things that don't exactly work yet, but they're coming, and it should be minor fixes. For example, the local ingress controller that gets deployed as part of Project Tye does not support WebSockets. So if I was trying to hit my application via that ingress when I was running locally, the SignalR stuff would not work. But once I deploy to Kubernetes, the ingress controller that gets deployed there does support WebSockets, and everything works fine as you saw. Kubernetes has thousands of configuration options. Certainly not all of them are available in Tye.yaml, but I think they're at an even lower subset than needs to be in order to be production ready. I was deploying a Blazor app, and other SPA platforms or WebAssembly, there are some challenges with that, especially with the service discovery, since the requests are really coming from your browser to talk to other services as opposed to one service talking to another within the cluster. So there are ways to do that with kind of tweaking with how it's hosted and publishing some configuration files and things when you actually launch the web app. But it's still kind of a challenge with any of the single page apps for that service discovery, as well as Blazor kind of behind the scenes. I did some stuff there to make it work. Blazor is one of the .NET technologies that it cannot natively containerize and host right now. So there's some work that had to be done. But in that case, if you get yourself in that situation, you can just write your own Docker file and configure it however you want. And instead of leveraging the built-in deployment, configure your own and have Tye run it. I mentioned as I was setting things up that prompt for the binding configuration is a little bit unclear of which one it's asking for. So it's just kind of in the order in which they're defined, but it'd be better if they were more clear about that. And I left this as sort of a limitation, even though it's as designed, is those dependencies are not deployed. So maybe within the context of your application, you want a message broker or you have some dependency that really only applies to your app. Technically, you could pull down that Docker file and create your own container image of that. But I think it'd be nice if there was a parameter or something where it says, hey, I know this is a dependency, but go ahead and deploy it with my application. So it's as designed, but could be nice to have that functionality. So some other features and future enhancements that they're talking about. As far as features go, if anyone's done anything, and I personally have done very, very little with Dapper, it supports that natively. Tye allows you to integrate Dapper. Diagnostics with Zipkin, Seek, logging, Elastic Stack. It's got native built-in support for deploying that and linking those in with the containers as well. It also supports Azure Functions. You can actually use Tye to deploy locally Azure Functions. If you're building a microservice architecture that also has some serverless components, you can integrate those in and deploy those and develop those with Project Tye. Right now, you cannot use Project Tye to deploy them, though, to a production or out to Azure. The other future enhancements that they're talking about is multi-repo scenarios. So basically having a Tye.yaml call another Tye.yaml. So the idea being you could have a team that is working on a microservices application that is completely separate from yours, but yours maybe leverages some components of that. You might not need to develop or do anything with it. You could just call a Tye.yaml file and then stack your own Tye.yaml stuff on that to build that out. So that's another enhancement they're looking at. And finally, I mentioned the one thing that maybe could find its way into production even now is the two commands Tye build and Tye push. So I've noticed you mentioned that for a .NET project, it can natively containerize and build that. If you've got a project that fits that mold that you don't need to really, handhold the creation of the Docker file, the container, leveraging Tye build and Tye push in some of your CI/CD pipelines could be valuable, where you just have Tye containerize it and push that container up to your repository. So it could simplify some of the deployment, and that stuff really works now. And that's, if you talk to Microsoft or view any of their documentation or videos on that, that's kind of what they talk about. A lot of people, if you're using Kubernetes, already have a CD pipeline that is reliable or have already been set up. But as far as getting your code containerized and published or pushed to a repository, Tye could be put into that process to make things a little bit easier for you. We'll share this out, some resources. Project Tye, open source on GitHub. All the documentation is there. There was an introductory video that was pretty cool that they did on the Channel 9 back on one of their coding conferences. And then all of the demo source code that I showed today is available on my GitHub under Johnny Rue's Project Tye demo. So if you want to check that out, you should be able to clone that down, type Tye run, and up you should come, assuming you have all the build resources on your machine. So that's it for me. I hope that was helpful. We've got a few minutes here for questions if any came in. Otherwise, we'll give people back their few minutes on a Friday.
Don't have any questions in the queue.
Awesome. Well, I'll either answer them all or people weren't paying attention. But anyway, this is fun. Hope everybody enjoyed it. If there are any questions at the end, feel free to reach out to me via any of the communication platforms, and we'll be in touch.